show some problems today, and tomorrow we're going to start circular motion. So today we will do some problems on NLM without friction. All right, here's the problem. First problem. All right, so I've got a problem saying there is a mass, two masses M and M. This is the configuration. The rod is of length L. This is M. Mass of the rod is M. This is eta times M. There's a ball here, which is eta times M, and the length of the rod is L. All right. Now the system is released. When this is released, I mean, they'll have accelerations. That constant equation you can tell me quickly. Then because of which, like one will go downward, the other will go upward, or if this goes up, this will go down, depending on what the eta is. If rod goes down and ball goes up, I have to find out time after which this ball will cross the rod. All right, that's the question. I have to find the time. How soon will the ball be opposite the upper end of the rod? How soon will the ball be at the opposite end of the rod? It's at rod, one end of the rod. Ball will accelerate upward, rod will accelerate downward, because of which rod will come. I mean, rod comes down, ball goes up. So at some point of time, ball will cross the upper end of the rod. I have to find out that time. How much time does it take for it to cross the upper end of the rod? All right. So first, tell me the constant equation for this one. If this is one is a naught, what is the acceleration of the other? Let's say the acceleration of the ball is a naught. What is the acceleration of the rod? A naught upwards, let's say. What is the acceleration of the rod? So who all we have here? We have Ashrita, Vignesh, Nikita, Shivani, and Nausheen. All right. So I'm asking you the constant equation. If the ball goes up with a naught, with what acceleration will the rod come down? A naught by 2, 2a naught, 3a naught, a naught by 3, 3a naught by 2, 2a naught by 3. You can either apply push-pull method or the pulley equation. Because one end of the string is fixed, I can apply the push-pull method. So can you tell me the constant equation? Vignesh, can you tell me constant equation? Are you all able to hear me? Am I audible? Students, am I audible? All right, all right. Okay, Shivani, it's audible. Fine, good. So, if this ball goes up with an acceleration a naught, rod comes up with an acceleration. How much acceleration do you think the rod will have? Mass is m. Masses don't matter right now. Constant equation is independent of the mass. It depends only on the configurations of the pulley, configuration of the system. So, if this goes up with a naught, with what acceleration does the rod come down? Sorry, yes, Signesh, what did you say? Okay, your voice is breaking. I don't know where the issue is. All right. Uh, okay. Seems like I don't know whether you got the answer or not, but I'll still go ahead with the explanation. If this goes up by x, this pulley comes down by x. This string staggers by x and x 2x. So this rod comes down by 2x. So this is a naught, this is 2a naught, not a naught by 2. All right. So what is the relative acceleration now? A naught plus 2a naught, 3a naught. So my ball will cross the rod with a relative acceleration of 3a naught. So it'll have half times 3a naught t square is equal to L. So t square is equal to 2L by 3a naught under root. So t is equal to 2 root of 2L by 3a naught. So all I have to do is find out a naught and plug it in this equation. All I did was s equal to ut plus half at square. L is equal to ut is 0, u is 0 plus half at square. A is relative acceleration is 3a naught. Why is it 3a naught? Because this is going towards right with upward with a naught. This is coming towards left with 2a naught. So relative acceleration of 1 with respect to 2 is 3a naught. Alright, a naught I cap minus 2a naught I cap, a naught minus of minus 2a naught. So that becomes a naught plus 2a naught, 3a naught. All I have to do is plug in a naught now. How will I find a naught? Again, FBD, reference frame, FBD, F is equal to MA. From there, I get the acceleration. So FBD of the rod is tension T mg. Downward acceleration is 2a naught. So MAD is complete. FBD is complete. I'll write the equation mg minus T is equal to m into 2a naught. Similarly, for the ball, this is 2T, this is eta mg. So I'll have 2T minus eta mg is equal to eta times m times a naught. I multiply this with 2, add these two equations, 2T gets cancelled out. I'll have 2mg minus eta mg is equal to just Vignesh, your voice is not clear. You type in the chat box otherwise. If the network is weak, type it in the chat box. Students, if you attend once in a while, you will not understand the class. If you attend once in a while, you will not understand the class, students. All right, it will be just like you're watching some uh, random video. Only if you follow the sequence, you will understand the class. But I'm still trying to explain every problem every time from scratch. Otherwise, we can solve the problems in minutes. But we are taking 10 minutes to solve a problem in class. In couple of minutes, we are supposed to solve every problem in couple of minutes, but we are still solving the first problem for next 5 minutes. We will be solving the same problem. All right. This is because I'm going from scratch for every problem. And that is happening because I see irregularity in you. Students are not regular. If you come once in a while, you will not understand the class. Now, tomorrow we're going to start circular motion. I'm sure. Again, tomorrow you will not appear. You'll appear again day after tomorrow. You'll not understand the class again. So, being irregular to class, you will not understand the class. All right. And which will be of no use at all. So, please take care of attendance. All right. Eta mg is equal to ma naught into 4 plus eta. So, m gets cancelled out. So, a is equal to g into 2 minus eta by 4 plus eta. All right, this is eta. Looks like n, but it's eta. All right, elongated n. I got the acceleration. This is a naught. I'll plug this acceleration in. Time is equal to root of 2L by 3a naught. Plug this acceleration here, that's your answer. All right, why did I take relative acceleration with 3a naught, not a naught? Because this is coming down with 2a naught, this is going up with a naught. Acceleration of ball with respect to the rod. If I stand on the rod and observe the ball appears to come towards the rod, other end of the rod, with an acceleration of 3a naught. All right, that's why I've taken relative acceleration to be 3a naught. Okay, let's go for the next one. And students, you have to start solving problems and you have to ask me doubts. If at all you have got any doubts, you will have to ask me. Send your problem in the WhatsApp. We'll discuss the problem in the class. All right, but start solving some problems. See, having exams in college or having homework from college is not the excuse. Okay, that's okay, but it's not the excuse every time. You have to manage everything. Ultimately, that will not fetch you the rank, right? If you don't manage, you will not get a rank. Mm. Because I've got an inclined plane. I've got two blocks, A, B, I mean three blocks, A, B, and C. Three blocks A, B, and C of 1 kg, 3 kg, and sorry, 1 kg, 2 kg, and 3 kg, right? Yeah, 1 kg, 3 kg, and 2 kg. This angle is 60 degrees. This angle is 30 degrees. All right, this wedge is fixed. I've determined the acceleration of the blocks and tensions in the string. Tension in the string, sorry. So how do I find the acceleration of the blocks? Let's see which component is beating which component. The component over here is 2g sine 30, which is 2g sine 30 is how much? How much is 2g sine 30? 2g into 1 by 2, it is g. Yeah. Now in this direction, I've got 1g, 1 plus 3g, 4g sine 60. That will be 2 root 3g.
हो गए.
Right. So if I can combine these two blocks together, it becomes a 4 kg block. 4g sine 60. 4g into root 3 by 2. 2 root 3g. So this is beating that. 2 root 3g is beating g. So this will slide down this inclined plane, slide down this inclined plane. Instead of this inclined plane, I mean, instead of going upward, 2 kg block comes upward, 1 and 3 kg blocks slide down. All right. Now I have determined the acceleration of the blocks. How do I do? Supporting force minus opposing force by total mass. Supporting force is 2 root 3g minus opposing force is g by total mass is 1 plus 3 plus 2. That is 6. So g times of 2 root 3 minus 1 by 6 is my acceleration. Yes, that's right. That's right, Vignesh. 2 root 3 is right. Okay. So how do I find the tension in the string now? This tension is what I have to find out. So tension over here, T minus G is equal to 2 into this acceleration. So T minus G is equal to 2 times of M into A. G into 2 root 3 minus 1 by 6. Okay, that's a, I take G on this side, I get acceleration to, tension in the string to be plus G. So that would be G into 2G root 3 minus 1 by 3 plus G. So that would be 2G root 3 plus 2G by 3. This is my tension in the string. Alright, T1. If this is T1, plus the tension in the string. Now tension in the string is also very simple. I'll not do that now. All I have to do is 1G, 2 root 3G or 1G sine 60 minus T2 is equal to 1 into A naught. Alright, I'll not do that. That's very simple. Okay, now let's go for the next one. This is M1, M1, M2. I've determined the acceleration of the blocks. But before that, I need to find the constraint relation. If this goes up with an acceleration A naught, this comes down with an acceleration. With what acceleration does M2 come down? M2 come down. If M1 goes up with an acceleration A naught, with what acceleration does M2 come down? Okay, it's a simple, yes, Vignesh, that's right. Good. Okay, so with what acceleration does M2 come down? If this goes up with an acceleration A naught, this slab is connected to two pulleys with a string here. One end of the string is fixed to the block. So I can use this push-pull method. How much does the string slacken? If I push this M1 by X, how much does the string slacken is what you have to see. Okay. Okay. So Vignesh, I don't know what the problem is. Maybe network issue, but others able to hear my voice clearly, or is there any lag? Okay, seems like it's clear. Vignesh, I think it's the problem with the network. All right. So what's the constraint relation? If this is A naught, what is the acceleration of this M2? Think, students. If the acceleration of the block is A naught, what is the acceleration of the block M2? If A1, M1 has an acceleration A naught upwards, what is the acceleration of the block M2? No, Vignesh, it is not 3A naught. Think again. It's pretty simple. Think again. You move M1 by X. See how much is the string slackened. I move this M1 by X. So string slackens by X, 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 X over here at X. So string slackens by 5X. So this comes down by 5X. So if acceleration is A naught, acceleration of this is 5A naught. Simple. All right. It's a look and say question. Now I'll draw the FPD and write F is equal to ma to get the accelerations. Ultimately required is the acceleration of the blocks. So if I get A naught, I get 5A naught as well. So but constraint relation is if this goes up by X, that comes down by 5X. So if this goes up by V naught, that comes down by V naught to 5V naught. If this goes up by A naught, that comes down by 5A naught. All right, linear motion. And there are a couple of things we have to discuss in constraint, but if you're comfortable with these constraints, basic constraints, I mean, this is not basic, of course, but still, I mean, these are look and say still. Vignesh, it is not 3A naught, it is 5A naught. It's a look and say. You cannot go wrong in such questions, okay? All right. Now I'll draw the FPD of M2. So M2G downwards, tension T upwards, acceleration 5A naught downwards. So MAD and MPD is complete. I'll write the equation as M2G minus T is equal to M2 times 5A naught. I draw the FPD of this block. It is 5T upwards, M1G downwards, I'll write 5T minus M1G is equal to M1 times A naught. I multiply this equation with 5, add these two equations, so 5T gets cancelled out. So I'll have G times of 5M2 minus M1 is equal to A naught times of 25M2 plus M1. So A naught is equal to G times of 5m2 minus m1 by 25m2 plus m1. I got A naught, acceleration of m1, acceleration of m2 is 5a naught. All right, that's pretty simple, right? I mean, there is nothing to do, nothing to think about. Just get the acceleration, constant relation, which is push-pull method. I'll get A naught and 5a naught. Then go to FBD, write equation individually for each block. For M2, I've written equation. For M1, I've written equation. I multiply one equation with some constant. I add to both the equations. Tension gets cancelled out. I'll get the acceleration of the blocks. If I want tension, I'll plug this acceleration in one of these equations. I'll get tension in the string. If at all asked. All right. Okay. All right. Next question is 70 kg and 35 kg block. All right. I've determined the acceleration of the blocks. Everything is frictionless. We are doing NLM without friction. Problems on NLM without friction. Yes, that's right. Vignesh, that's absolutely right. That's good. Okay, now focus on this question, Vignesh. Everyone. Yeah, that's absolutely right, Vignesh. All right. Now, I will again determine the acceleration of the blocks. So, if acceleration of this one is A1 and acceleration of this is A2, or let's say this is A0, what is the acceleration of this block? How do I do this? Again, I'll use push-pull method. If this block moves by X, string slackens by 2X. If this block moves by Y, string tightens by 3Y. 2X is equal to 3Y. X is equal to 3Y by 2. So A0, and that would be 2A0 by 3. Think about it. I'll repeat the argument. What do you think about it first? So what's the constant relation? If this is A0, what is the acceleration of this block? I also told you the argument, but I want you to do it again. Yes, that's right, Agnesh. Yes, that's right. This goes by X, so string stack is by 2X, whereas this tightens by 3Y. 2X is equal to 3Y. If I differentiate, 2A0 is equal to 3A0 prime. So A0 prime is equal to 2A0 by 3. So acceleration of this is 2A0 by 3. All right. Now, once you get the acceleration, I'll again next is FBD and F is equal to MA. That's it. I choose ground as reference frame. With respect to ground, if tension is at T in the string, with respect to ground, the force on this is 300 Newton towards right, 3T towards left, and MAD is 2A0 by 3 with 35 kgs as mass. And of course, there is normal reaction in MG, but which is not coming to picture because the block is going horizontally. Thus, I am not drawing NN, MG and normal reaction. All right, but they do exist. All right, a complete FED will have normal reaction and 35G as well. So equation for this is 300 minus 3T is equal to 35 times 2a naught by 3. For this block, 2t is equal to 70 times a naught. How do I solve this equation? I multiply this equation with 2, multiply this equation with 3. T gets cancelled out. I'll add these two equations. T gets cancelled out. I'll get a naught from here. Can you tell me what is a naught? I multiply this with 2. I multiply this with 3. And add them. All right, can you solve these two equations? If you can solve, I'll go for the next problem. There's an inclined plane. Angle of inclination is 45. 45 degrees. On this, there's a particle with respect to this line parallel to the base. The particle is projected at velocity v naught at an angle of 45 degrees. All right. And v naught is 10 meter per second. Now determine the eventual motion of the ball. The ball is projected, particle is projected with velocity v naught, which is 10 meter per second at an angle of 45 degrees. I have to determine what happens to the ball eventually and how does the particle actually go. Now look at the students. In this plane, I've got an acceleration down the plane like this. And velocity is at an angle with the acceleration. So they are not making 180 or 0. Cross product is non-zero, so it will be a parabola with respect to this plane and with axis parallel to this acceleration vector, where if g is downward, this is g sine 45, g by root 2 is my acceleration down the plane. So it is g by root 2, parallel to g by root 2 down the plane, I've got a parabola with axis parallel to g by root 2 down the plane. Okay, that's how the particle will go. So I can determine the equation of trajectory, I can determine the time of flight, I can determine range, anything. So required to find the equation of trajectory of this particle, with presuming this is origin. This is x-axis, this is y-axis, and this particle launch of point of launch is origin. So I have to find the equation of this trajectory. So how do I do it? I know that y is equal to x tan theta minus gx square by 2u square cos square theta is my equation of trajectory. But here instead of g, I've got g by root 2. So all that I have to do is I have to replace g by root 2 and theta is 45. So x minus gx square by 2 root 2 v naught square cos square theta, which is 1 by 2. So 2 gets cancelled out. I'll have y is equal to x minus gx square by v naught square root 2 or root 2 v naught square. Alright, so this is the equation of trajectory. With x and y as axis as shown and point of launch is origin. Is this clear? I don't understand what's the problem. So, I mean, I'm unable to hear you all. Yeah, Shivani, sure, sure. That's good. Look at this. I feel good when you ask it out. All right. I feel good when you express yourself that you're not understanding or you're not understanding or not. That's good, Shivani. Thank you. All right. See, I've got a inclined plane like this. ఇలా ఒక ఇంక్లైన్ ప్లేన్ ఉంది. దీనిపైన ఒక పార్టికల్ ని ఇలా ఇలా వదిలేశారు. ఈ యాంగిల్లో వదిలేశారు. రైట్ విత్ అన్ యాంగిల్ ఆఫ్ 45 degrees. ఇలా వదిలేస్తే దిస్ పార్టికల్ విల్ గో ఇన్ పారాబోలిక్ పాత్ లైక్ దిస్. With the axis of the parabola parallel to g by root 2 acceleration vector, which is g by root 2 here. Why is it g by root 2? The angle చూస్తే g is downward. Component of g along the plane is g sine 45. Sine 45 is 1 by root 2. So g by root 2 is the acceleration down the plane. And that is down the plane. Right? It's parallel to this line, down the plane. So my parabola will be having an axis parallel to this acceleration vector, which is down the plane. Right. So I know the equation of trajectory is given by x tan theta minus gx square by 2u square cos square theta. All right, this is the equation of trajectory. This you have to remember. Otherwise, you will have to derive it. It will take another minute. So better remember this one. Once you know this one, all I have to do is replace g with g by root 2. Because my acceleration instead of g, I've got g by root 2. This is for the acceleration g downward, right? This equation of trajectory is for a particle launched in air under acceleration due to gravity. All right, on Earth, with where the acceleration due to gravity is g. So, but here I've got down the plane, which is g by root 2. Acceleration due to gravity is g by root 2 here. Down the plane, acceleration is g by root 2. So I'll replace g with g by root 2. I'll get the required equation. So I'll replace g with g by root 2. And theta is 45. So tan 45 is 1. X tan theta minus gx square by 2 root 2. V naught square cos square theta. Theta is 45. So cos theta is 1 by root 2. Cos square is 1 by 2. This 2 gets cancelled out. I'll get x minus gx square by V naught square root 2. Is it okay now? All right. Good, good. Okay. So what is the time of flight? No. So how much, like after what time will the particle go parallel to the base? The baseline ki parallel epudu avutundi. That is at the maximum height. At maximum height, what is the time of flight? How much time does it take from point of launch to the maximum height? Time of ascent, which is V naught by or V naught sine theta by A, which is G by root 2. Root 2 gets cancelled out. I'll have V naught by G. Yes. So this is time of ascent. So this is the time after which the particle goes parallel to the base. And at what time will the particle again come back to this level? 2 times the time of flight. At time of ascent or time of flight. Where time of flight is nothing but 2 times of this one. So 2E by G is my time of flight. Time after which the particle will again come back to the same level on this inclined plane is time of flight, which is twice the time of ascent. All right, look at this. This is not down the inclined, it is on the inclined plane. This particle's trajectory is on the inclined plane. This is a planar motion with the particle moving on the plane of on the surface. It is not projected like this. ఇలా ప్రొజెక్ట్ చేయట్లేదు, ఇలా రావట్లేదు, ఆ ప్లేన్ మీదనే వెళ్తుంది. ఆల్ రైట్, దట్స్ ద డిఫరెన్స్. ఈ పార్టికల్ ని ఇలా ప్రొజెక్ట్ చేయలేదు, ఇలా రావట్లేదు, ప్లేన్ బయటికి రావట్లేదు. It is moving on the plane itself. So planar motion is the plane of motion is this hypotenuse of the wedge. All right. Hope that's clear. How will I find the range now? I'll use the range formula, but except that I'll use g by root instead of g. Whatever is the range formula, whatever is the height, maximum height formula, I'll use the same formula, but except g instead of g, I'll use g by root 2. All right. Okay. Now let's go for a problem. We'll discuss, and then I'll leave that problem to you. You think about the problem because I tell you always that keep thinking about a problem every time. have a problem in mind always. Always have some or the other problem in mind. Or it's some problem. It could be math, physics, or chemistry, but I would ask you to have physics problem. But thinking about a problem will help your think faster in exam because you'll always be acquainted to keep your brain active. All right. Now, all right, here is the question. I've got a rope of length 2L, rope length 2L, 2L naught, with linear mass density lambda naught, or total mass is M. All right, anything. You take either lambda naught or M, right, in anything. But ultimately, I want in terms of M naught and L. I mean, ultimately, you will have in terms of independent of M that you have to see. But now the question is, I've got a rope which is hanging like this, where this is length L naught, this is length L naught. So total length is 2L naught, but this is hanging in equilibrium like this. This will always be in equilibrium because here mass over here and here is same. So that will be in equilibrium. Now the question is, now the scenario is, I displace this a little. ఇది కొంచెం కింద చేసి ఇది వదిలేస్తాను ఇలా. Balance ని disturb చేసి వదిలేస్తాను. So because this is longer in length, so more mass over here, less mass over here, because of which it will start accelerating. Right? This part comes down, this part goes up. The question is, what is the velocity of the rope when this whole rope is finished? When this whole rope comes to the right part. All right, that's the question. And velocity and time. You need both. I need to find the velocity with which the velocity of the rope when the configuration changes to this one, and time after which this will change. All right, that's the question we have got. I suggest you to think about this question today. We'll solve this question tomorrow. In fact, I'll send you one more question based on this. Just a second. Sorry?
So can you?
Yeah, you want to repeat it?
So,
Okay. See, I've got a rope. Length 2L. Think pulley is very small, point pulley. All right. I'm just to magnify, just to explain you things, I'm magnifying the pulley, but pulley is point pulley. All right. So, ఇలా ఉంది పుల్లి ఒక ఒక హుక్ ఉంది దాని మీద రోప్ ఇలా పెట్టారు లెఫ్ట్ సైడ్ లెంత్ ఎల్ ఉంది లెఫ్ట్ సైడ్ లెంత్ ఎల్ ఉంది రైట్ సైడ్ లెంత్ ఎల్ నాట్ ఉంది సో దట్ మీన్ ఈక్విలిబ్రియం ఇప్పుడు ఈక్విలిబ్రియం ఉంటుంది అలానే ఉంటుంది ఇది కొంచెం డిస్టర్బ్ చేశాను అనుకోండి రైట్ కి కొంచెం పుల్ చేసి ఇది వదిలేశాను అయితే ఇది మాస్ ఎక్కువ ఇది కిందకి వచ్చేస్తుంది కదా still strip down and this will go up. This will go up, come down with an acceleration, same acceleration. This will go up with an acceleration a naught. At that instant, its acceleration will be a naught. But the acceleration is going to be variable acceleration because mass is going on varying. Mass right side, left side tagutundi, mass right side increase avutundi. So my acceleration will also vary. So it's not constant acceleration motion. So for which I will use integration. The question is, after what time will this rope completely come to this point? మొత్తం L towards right side కి L వచ్చేయాలి 2L వచ్చేయాలి and time after which this happens and what's the velocity when this configuration is achieved. Is it clear now?
Yes, sir.
All right. Okay. All of a sudden, you people are active now. Okay. Good. Think about this problem. I'll give you one more. And this kind of problem we haven't done it before. This kind of problem we have done while doing chains and rope on a table. We have done it, but let's do this again. I've got a rope. Okay, sorry, a rod. This is frictional surface. Coefficient of friction is mu. This is frictionless surface. Coefficient of friction is 0. Here, coefficient of friction is mu. All right. So this side is frictional surface. Coefficient of friction is mu. Here it's 0. Now what I do, I project this rod of length L naught with velocity V naught towards right. All right. Now because this goes towards right, this enters into the frictional surface. Okay, mass of this is m. Because this enters the frictional surface, there will be friction, kinetic friction, because velocity of the rod with respect to ground is towards right, friction will be towards left. So when the rod enters the frictional surface, there will be friction towards left. Right? Friction towards left because it will start retarding. All right. So I have to find out with what is the minimum velocity for it of projection such that whole rod enters the region here and time after which it will stop. I have to frame the equation of motion ultimately. All right, then I'll solve it. You just think of framing the equation. I'll repeat the situation. ఒక రాడ్ ఉంది, ఒక ఫ్రిక్షనల్ సర్ఫేస్ ఉంది, లెఫ్ట్ సైడ్ స్మూత్ ఉంది, ఇక్కడ వరకు స్మూత్ ఉంది, ఇక్కడ నుంచి ఫ్రిక్షన్ ఉంది. ఇక్కడ కోఎఫిషియంట్ ఆఫ్ ఫ్రిక్షన్ ఇస్ న్యూ, ఇక్కడ కోఎఫిషియంట్ ఆఫ్ ఫ్రిక్షన్ ఇస్ 0. దిస్ ఇస్ స్మూత్ అండ్ దిస్ ఇస్ రఫ్. Frictional surface, frictionless surface. Smooth surface, rough surface. I project the rod with velocity V naught. Once it enters into this, and it's exactly at this position initially, at this origin, let's say. Once it enters into this one, x, a little bit by x, there is kinetic friction which is opposing the relative motion, because of which it will start retarding. So it will start retarding. So it can stop after a while without completely entering into this frictional surface. But the question is, what should be the V naught? Condition for that. Condition is the whole rod should enter the frictional surface. ఈ రాడ్ మొత్తం ఇక్కడ వచ్చేయాలి. ఇక్కడ వచ్చినాక ఆగాలి. అట్లీస్ట్ ఇక్కడ ఆగాలి. ఇక్కడ కూడా ఆగొచ్చు. బట్ అట్లీస్ట్ లోపలికి వెళ్ళాలి మొత్తం. ఫ్రిక్షనల్ సర్ఫేస్ కి వచ్చేయాలి. ఫ్రిక్షనల్ సర్ఫేస్ మీద వచ్చేయాలి. It should slide over the frictional surface, completely entering into the frictional surface. Completely entering into the means the other end of the rod should reach this origin. So this other end of the rod should reach origin. So what should be V naught such that the other end of the rod reaches origin? Or this whole rod enters the frictional surface and stops. And once it stops, friction disappears, no force, no external force, it will be there itself. Alright, so I have to frame the equation of motion. That's what you think about it. So how do we go about this problem? That's what you think, because mass is variable now. Look at this. When I write mu mg, mu into n, kinetic friction is mu into n is equal to mg. Now n is varying. So friction is varying. If friction is varying, my force is varying. If force is varying, acceleration is varying. So I'll use integration again. Alright? Have you understood this question? You think about these two questions today. Alright? Even if you have exams or something, but please keep this question in mind in lunch hour or whenever you have free time. And today, if it's a holiday, you please think about this problem. Give some time to this, give a thought to this, give some time to this problem. It is good if you keep thinking about a problem 24/7. Alright, that will help you. ఒక ప్రాబ్లం రాలేదంటే అది you keep thinking about it. ఇలా చేస్తే ఏమవుతుంది, అలా చేస్తే ఏమవుతుంది, what if I project with very high velocity, what if I project very less velocity? Alright, what if I project if this is rough and this is smooth, ఏమవుతుంది? Alright, also scenarios you keep thinking. Alright, we'll solve this problem tomorrow, but tomorrow we're going to start circular motion. Or shall we do problems on friction again? This is NNM without friction. Shall we do some problems on friction? Some critical problems on friction?
Yes, sir.
Or shall we move on to circular motion?
Few more on friction, sir.
All right. Then we'll do it. All right. So I'll send some problems to you, or no, I'll solve some problems tomorrow in the class. All right. The solve for today will stop here, but I request you all to please be regular. All right. Regular lekunte, you will not understand the class, and so that will be very boring and torturous to listen to something which you are not understanding. All right. And ultimately, the goal is not achieved. All right. So bye everyone. Thank you all. Have a great day.